Okay, here in this first video for the Unit 7 Ultimate Review, I'm going to look at numbers 1, 2, and 3. And as I'm working, I'm showing the problem number 1 on the left side, and on the right side, here's where I'm going to show the work and any other things that you should be showing on your paper. Number 1 asks us to write equations of circles. Number 1 says write the equation of the circle with a center at -5, -3, and a radius of 16. And you have to know the graphing form of the circle equation, which is x minus h squared plus y minus k squared equals r squared, where r is the radius, so there's your radius, and the center we get from the point h and k. So the whatever numbers with the x gives you the x coordinate of the center, and whatever's with the y gives you the y coordinate. Now to plug these in, what I'm doing is first plugging in the -5, -3 into the x and into the h and the k. So now this becomes x minus -5. And many of you probably don't need to show this step that I'm showing right here because a lot of you know the patterns. But just showing where the work comes from. Y minus -3 is going right here. Squared equals, and then the radius is also plugged in. They give you that radius of 16. That becomes 16 squared here. And as I start to simplify this now, I'm going to make this x, because the minus and negative cancel each other. That becomes x plus 5 squared plus y plus 3 squared. And then on the right side, I do have to multiply that 16 squared, so I'm going to do 16 times 16, which is 256. Now, many of you probably, again, didn't need to show this step right here, because from the patterns you know just to change the signs. When you plug in, it becomes x instead of -5, opposite as positive 5 squared, plus y instead of -3, positive 3 squared. And again, on the right side, 16 squared is 256. Now for the second one in number 1, it asks to write the equation of the circle with the center at -5, -3, so it's almost exactly the same. It's going to be, oh, I put -5 there, x plus 5 again, quantity squared, plus y plus 3 quantity squared equals, what's different now though, just notice that they gave you a diameter of 16. Instead of a radius, they gave you the diameter. So remember that if I draw the circle, when I draw a circle, that's my radius, but remember that all the way across is my diameter. So this whole thing, there's my diameter all the way across. So if they're telling me that the diameter is 16, that means if I cut the 16 in half, it becomes 8, and 8, there's my radius. The radius is actually 8. So when I plug it into the formula, it becomes 8 squared. 8 squared is 64. So there's my two equations in number 1. In number 2, we're asked to write the equation in standard form and then graph the result below. And they're giving us this equation with x squared plus y squared minus 10x plus 12y plus 3 equals 0. And hopefully you notice right away that since both x and y are squared, this is going to be a circle, which means eventually I have to have something that looks like this. There's x, there's y. You just have to figure out what's going in with each variable and what the radius is. Now, if you remember something called completing the square, then you'll be able to do this one. So I'm going to start by writing that big long equation, x squared plus y squared minus 10x plus 12y plus 3 equals 0. And the first thing I'm going to do is I'm going to take that 3, I'm going to move that over. I'm going to subtract 3. So that's now on the left side, and on the right side. And then on the left, I'm going to start by arranging my x's together. I'm going to start with x squared minus 10x plus blank. Now, depending on how your teacher showed you, there's different ways to fill in that blank. Some of them might have shown you a formula that looked like this: b over 2 squared. What I typically did is I showed the diamond, where the -10 would be on the bottom. But the idea of the diamond is that eventually, if we want it to look like this, which means that this number and this number have to be exactly the same number, and they have to add up to -10. To do that, -5 is the only one that's going to work. -5 plus -5 is -10, which then helps you fill out the top of the diamond. Multiply them together, you get +25. That's what's going in that first blank. And you have to put that 25 in both sides. Which means that when we factor this to get it down here, this is now going to be x minus 5. And one quick pattern, if you're using a diamond, whatever you get on the left and the right of the diamond, that's what's going in there with the x term. So I know right off the bat that part of my equation is going to start with x minus 5. Now I'm going to go to the y's, and I'm going to arrange the y's together. Y squared plus 12y plus blank. And since I put a plus blank, I'm putting that again over here, and it's the same process. This time on my diamond, I have +12 on the bottom. 6 plus 6 is 12. Now I've got those numbers to match. 6 times 6 is 36. That's what's going here and here. Plus, now I can factor, and again, look at the diamond, that +6 on both sides, that's what's going in with y. +6 means y plus 6. On the right side, I'm going to combine all those together, -3 plus 25 plus 36, and I get 2258. So now, I've got my equation set, and I've got +6 here, and I've got 58 here. Now I'm ready to start graphing it. And the center is easy. The center, remember, you're doing just the opposite of what's inside with the x and the y. So my center, I'm going to have +5 because of this -5 changing to positive. And I'm going to have -6 for my y coordinate because of this +6 becoming negative. So if I graph 5, -6, 5, -6, I'm all the way down here. And this is actually going to go off just a little bit, but that's fine. The next thing I'm going to do is I'm going to try to find the radius. Now to find the radius, I need to take that 58 that's by itself on the right side, and I need to take the square root of it. And when I plug that into the calculator, it rounds to about 7.6, so it's close to 7.5. Now what that means is when I graph it, I have to count about 7.6 up, down, left, and right from the center point. So now I'm going to take the center, I'm going to count 1, 2, 3, 4, 5, 6, 7.5 is in between right there, so I've gone up 7.5. Left 1, 2, 3, 4, 5, 6, 7.5. Right 1, 2, 3, and I'm going off the grid. 4, 5, 6, and that's about there. And now down 7 is going to go way off the grid. 1, 2, 3, and that's going to estimate. And it's kind of on my computer screen. You can see it there at the bottom. And then I'm going to draw my circle through those 4 points. So a nice, beautiful, perfect, exact circle. There is number 2. Number 3 is the last one in this video. Number 3 is a much easier one. Asked, does the point 9 and 9 lie on the circle with the equation? And then they give you this equation here. And to do that, you don't need to graph anything. All you're doing is you're plugging in. You're checking it algebraically. So what you're doing is you're taking that point 9 and 9. You're plugging this 9 in for x, this 9 in for y. So now when I go to the equation, instead of this x minus 4, it becomes 9 minus 4 squared. Plus, and then instead of this y, that becomes 9 plus 3 squared equals 169. In order of operations, I'm going to subtract inside, I get 5 squared plus, add inside, I get 12 squared. 5 squared is 25. 12 squared is 144. And when I add those, I do get 169. And those two numbers do match. They are congruent, so yes, it does lie on that circle. If you got anything other than 169 at the end, if those numbers didn't match, then no, it wouldn't work. It wouldn't be on the circle.